Hey guys, Mr. Yisley here. So we're going to move on and talk about slope-intercept form of linear inequalities in two variables. So slope-intercept form, right, of linear inequalities in two variables. Now if we just recall our information about slope-intercept form with linear equations, it was y equals mx plus b. Y equals mx plus b. Well, to be honest, there's no real difference between slope-intercept form with linear equations and slope-intercept form of linear inequalities except for one little thing, which is the sign right here. Before with linear equations, that was always an equal sign. With linear inequalities, it could be the greater than, could be the less than, could be the greater than or equal to, or the less than or equal to. But the rest of it is still the same. We're still going to have slope here. We're still going to have our y-intercept here. So slope in front of x, y-intercept, and that's the y-coordinate, of course, of the y-intercept after the x. That stuff is still going to be the same. So in this section, what we're going to talk about is how to rearrange a linear inequality into slope-intercept form. And to be honest with you, this process is no different than how we rearranged linear equations to slope-intercept form. There's only one thing that you really need to remember. But it always starts with if we have a problem that is in the form of, reminder, ax plus by, it will say greater than c. All right, so if we have a problem that falls in that form, the first thing we want to do is get the x off the same side as the y. So we need to move the x across. And remember, that happens by doing the opposite of what it is. So if it's positive, we're going to subtract it. If it's negative, we're going to add it. And as we learned in a previous chapter, in chapter 2b, we talked about that when we add or subtract something across an inequality, it doesn't change the inequality symbol at all. So we're going to add or subtract the x across to the other side to try to get the y by itself. After we've moved the x across and we now have the y by itself, so like in our one out here to the side, if I subtracted ax and I would subtract ax here, I would be left with by is greater than negative ax plus c, because we talked about we always want the x term first. Then we want to divide by the coefficient of the y. So that's the number that's in front of the y. In this example, it's a letter, it's b, right? But we want to divide by that coefficient that is multiplying y. And that includes if it has a negative in front of it. So in this example, it doesn't, but we're going to divide by the coefficient. Now, please remember, when we learned about this back in chapter 2b, that if you divide by a negative, the inequality symbol reverses. So if you divide by a negative, the inequality symbol reverses. So if it's a greater than, it becomes a less than. If it's a less than, it becomes a greater than. It just flips the other direction. And we talked about back in chapter 2b why that happens. But again, it's just really one of those rules we got to remember. Now, if we divide by a positive number, that does not change the inequality symbol. So those are just some of the things we need to recall from previous chapters. All right, but the process, again, get the x's across off the same side as the y by adding or subtracting, then divide by the coefficient that's in front of y that's multiplying it. All right, well, let's take a look at an example then. So example A here, we have 2x plus 3y is less than 6. So my first step is I want to get the x's off the same side as the y's. So I see that it's a positive 2x, so my first step is to subtract 2x, which means I need to subtract 2x here. I've got to move this x across here, right? And because it's positive, I'm going to subtract it. Well, 2x minus 2x, that's 0, so those cancel, and I'm left with just 3y, which is less than, broke my lead, less than, and then we want the x's first, so negative 2x, and then this is a positive 6, so plus 6. Now you're probably saying this looks really familiar, right? Well, it should. This is the exact same process we went through with linear equations. So then my second step is I need to figure out, is there a coefficient, or what is the coefficient of y? Well, the coefficient is this positive 3. So I'm going to divide each side by 3. That's my second step. So I'm going to divide by 3 and divide by 3. Now 3y divided by 3, when you divide by the same number you're multiplying by, we've talked about that really just means 1, so they cancel and we're left with just y. Now dividing by a positive number does not change our inequality symbol, so it's going to stay as less than. And then we need to divide each term individually. Well, negative 2x divided by 3, that does not go evenly. So we're going to have a fraction in front of x, which we've talked about is okay because we like them actually to be in fraction form because that helps us when we're graphing with our slope. So negative 2 divided by 3, that's already reduced down, so I'm going to leave that as negative 2/3. Bring the x down. Then I need to divide 6 by 3. So 6 divided by 3 is 2, and a positive divided by a positive is a positive. So my final linear inequality in slope-intercept form is y is less than negative 2/3 x plus 2. All right, well, let's move on to example B here. So example B says x plus 2y is greater than or equal to 6. So first step again, we need to move these x's across. Well, according to this, I only have the one x and it's positive, so that means I need to subtract x from this side, which means I also need to subtract it from that side. X minus x is 0, that cancels and we're left with 2y. Again, subtracting does not change the inequality symbol, so greater than or equal to. I need my x's to be first, so that's negative x, and then that's a positive 6, so plus 6. Now my second step is I need to divide by the coefficient of y, which is the 2 here. So I'm going to divide each side by 2 and everything on both sides. So divide by 2 and divide by 2. 2 divided by 2 is 1, so we're left with just y. Right, now I'm dividing, but it's by a positive, so no change to the inequality symbol, so greater than or equal to. Now I've got negative x divided by 2. Well, it's hard to divide something if we don't see the number, so we always remember that variable of any kind, if it doesn't have a number listed in front of it, it really means 1. So really what I have is negative 1x divided by 2. Well, again, 2 does not go evenly into negative 1, so we're going to leave it as a reduced fraction, which would be negative 1 over 2. Bring the x down. And then the second term, positive 6 divided by 2, is positive 3. So my final answer there, y is greater than or equal to negative 1/2 x plus 3. All right, well, I'd encourage you at this point, hopefully you're kind of getting the steps to it and it's reminding you of the linear equations, is to try example C on your own. So pause the video, then check your answer with mine. So example C, again, first thing I want to do is get the x's off the same side. So I need to move that 3x. Well, again, it's a positive 3x. So I'm going to subtract 3x from this side and subtract 3x from that side. When I do that, 3x minus 3x, that cancels, and I'm left with 4y. Subtracting does not change inequality symbols, so 4y is less than or equal to. And then I want my x's first, so negative 3x, that's a positive 12, so plus 12. Last step, or second step, is to divide by the coefficient in front of y, which is this 4 right here. So I'm going to divide each side by 4 and everything on each side. So 4y divided by 4, we know that those 4's cancel, and we're left with just y. Now again, divided by a positive number, so no change to the inequality symbol, so that's less than or equal to. Then I need to divide my first term on the right side, so negative 3x divided by 4. Well, 4 does not go evenly into negative 3, so again, leave it as a reduced fraction. So this is going to be negative 3/4. Bring the x down. And then second term, 12 divided by 4 is positive 3. So my final answer on C is y is less than or equal to negative 3/4 x plus 3. All right, well, we got one more example. I'd encourage you to try example D on your own, then check your answer with mine. So example D says 2x minus 5y is greater than or equal to 10. So first step is move the x's off the same side as the y. So again, it's a positive 2x, so I'm going to subtract 2x from this side, which means I also have to subtract 2x from that side. Now 2x minus 2x, that is 0, or cancels out, and I'm left with negative, because there's a negative right there, negative 5y greater than or equal to, again my x is first, so negative 2x, and that's a positive 10, so plus 10. Then my next step is to divide by the coefficient of y, including if it has a negative, which this one does. So y is being multiplied by negative 5, so I need to divide by negative 5. So negative 5 divided by negative 5, that is 1. So we know those cancel and I'm left with just y. Now when I divide, if I'm dividing by a negative, that's going to flip my inequality symbol. So it's going to change from greater than or equal to less than or equal to. So don't forget to check if you need to do that. Then we need to divide each term on the right side by negative 5. So negative 2x divided by negative 5, well, I know that 5 does not go evenly into 2, so I'm going to make sure that it is a reduced fraction, which it is. So we're going to have 2 over 5, and then a negative divided by a negative is a positive. So this becomes positive 2/5 x, bring the x down, and then positive 10 divided by negative 5, 10 divided by 5 is 2. A positive divided by a negative is a negative. So my final linear inequality in slope-intercept form is y is less than or equal to 2/5 x minus 2. All right, well, if you have any additional questions on moving linear inequalities into slope-intercept form, please let me know. Otherwise, you can continue on in the chapter.